Okay, well now we're at the time of year in geometry where we're learning about area, volume, and surface area. And what's happening? You're getting a load of formulas thrown at you, one after the other, and you're basically being asked to memorize them. Hopefully when you see a problem, you come up with the right formula. But you know what? Exams are less often giving you the formulas and you really have to know them. No! The purpose of this video is to obtain an understanding of each one of these formulas. Now let's talk about surface area. What? Surface area is what you think it is. It's the area of all the surfaces of a shape. So let's start with the most basic one, the box, the rectangular prism. Think about a number cube or think about any box you might have. How many sides does it have? That's right, it has 6, okay? And they're all rectangles. So you got yourself 6 rectangles here, okay? And you're like, oh man, I gotta do 6 calculations here? Well, no, absolutely not. Because if you look at a standard prism, the top and bottom are the same, the left and right are the same, and the front and back are the same. So you really have 3 sets of 2 dimensions. So what you would do is, let's say you have a 2 by 3 by 5 rectangular prism, and the order doesn't matter, okay? You're going to take each set of 2 and multiply it twice. What do I mean by that? One side is going to be 2 times 3, another side is going to be 3 times 5, and the final 2 sides are going to be 2 times 5. And you're going to take each result and you're going to multiply the whole thing by 2. So it really isn't 8 calculations, it's really 4.
I can do this. I can do this.
And if you come up with all this and add this up, 2132 times 31, so the volume of this is 62, and let's go inches cubed, because I'm sure your teacher wants you to put in the unit of measure. Now the next shape is also a prism with 2 bases, but the bases are triangles, okay? Picture a doorstop, let's say, or even a tent, where the front and back are the bases. So the bases are 2 triangles and there's 3 rectangles wrapping around them. Okay, so it's the area of each one of those surfaces. So if the shape is 2 triangles and 3 rectangles, well, what's the formula for the area of a triangle? That's right, we just covered it. 1/2 base times height. But since there are 2 of them, and there's 2 1/2s, you can just calculate base times height of the triangle. So now with these 2 covered, you would add the area of each one of the 3 rectangles, and each one of them would have their own length times width. Now let's talk about a cylinder, the surface area of a cylinder. Now what is a cylinder made up of? Well, the top and the bottom are both circles. So you have 2 circles. The question is, what's this stuff?
What is that?
Well, it's just a rolled up rectangle. So you actually are dealing with 2 circles and 1 rectangle. Now, the area of a circle is pi r squared, and since there are 2 of them, that's right, 2 pi r squared. So that takes care of the area of the 2 circles. Now let's focus on the area of the rolled up rectangle. We know that the area of a rectangle is simply base times height, but now it's all rolled up. So let's see how it affects the base and the height. First, let's focus on the height. If I roll it up, does the height of the rectangle change? The answer is no. So we're still going to multiply the height. Now here's where the fun begins. We're back to our rectangle. Here's our rectangle. Our height stays the same. Now I want you to focus on the base.
Focus. 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 Focus.
Okay? When we roll up the rectangle, look at that. It becomes a circle, and it's the distance around a circle. And who remembers the formula for the distance around the circle? First of all, it's called a circumference, and the distance around a circle is 2 times pi times radius. And that's how you get the formula for the surface area of a cylinder. 2 circles plus 2 pi r times height. Now let's talk about the surface area of a cone. And we're talking about a shape that has a circular base, but only one base, right? So there's only one circle. So a cone is made up of one circle, and the formula for the area of a circle is pi times the radius squared. Now we have a unique situation where the sides, the roll around, the rectangle if you will, is rolled, it's bent inward and slanted. And there's a new concept here, and it's called the slant height. And in the infinite wisdom of math people, they designate slant height, not as S, not as H, but a script letter L.
What?
I don't know why. So, the rest of the cone, it's the area of the circle, but instead of multiplying the radius twice, you're multiplying by this concept called slant height. And if you could picture the cone, here's your circle, the slant height is going like this. Now sometimes you're just going to be given the slant height, so just follow the formula. Sometimes you're going to be given the height of the cone and the radius of the circle. Look what we have here, boys and girls. If this is the radius and this is the true height of our cone, which stands straight up and down, do you see what we have here? We have a right triangle, and they're relying on you to come up with the slant height. Hopefully, on a formal exam, you're given slant height, but if not, you will be given the radius and you will be given the height of the cone, and we're just going to use that good old-fashioned Pythagorean theorem again. A squared plus b squared equals c squared, except one is going to be the height of the cone, one is going to be the radius of the circle, and your result is going to be the slant height. If any of you are struggling with this or any other concepts, please don't hesitate. Go to www.creativetutoringllc.com for more information.